So when we split up the force due to gravity into its x and y components, both down. So for normal force, we would have 0 in the x, right? Okay, so normal force, we have none in the x. Tension, we have nothing in the y. What about the net force? 0 in the y. Wouldn't the net force also, we're looking for the acceleration, wouldn't the net force be 2 times the acceleration, mass times a? Does that make sense? And that's what we want to solve for. We want to solve for a. Force due to gravity, wouldn't the x component of gravity be 2 times 9.8 times cosine 60 degrees? That'd be in the negative x. Everybody okay with that? We could get the y components as well. But really, this is going to be negative 19.6 sine 60. This will be positive 19.6 sine 60. Cancel out. We're actually not going to use that, so we don't even need it. Tension, we don't know, so let's call that T. If I add up that left column, if I add up all the x halves, what happens that might not necessarily be quite so good? Yeah, that's okay. Tension's in the positive, that's in the negative. 2 variables, good. What happens if we have 2 variables? What do we need? We need another equation, right? We need 2 equations. We can set up one equation, negative 19.6 cosine 60. Cosine of 60 is 1/2, so that'd simply be negative 9.8 plus t equals 2a, which is good. I need that. But since I have 2 equations, since I have 2 variables, I need 2 equations in order to solve. Where do we think the second equation is going to come from? Yeah, the other block. So if I do the free body diagram with this block, gravity pulls it straight down, tension's pulling it that way, and normal force pulling it straight up. Since this tension, the tension in this rope here is the same as the tension in this rope here, I can call them both T. They'd be the same, right? I'm going to call the direction that this whole thing's moving the positive x again, and perpendicular to that positive y. Force due to gravity would be what? Again, we're only going to need x components. We're not going to need to worry about the y. Good. 19.6 cosine of 30 degrees. And the positive or negative x? Yeah, this one's positive, isn't it? That triangle too. Positive x direction. It would be in the negative y. We don't go through that. Normal force is 0 in the x. What about tension? It is just T in the positive or negative direction. And the net force is again going to be 2a, right? So we need 19.6 cosine of 30. Cosine 30 is 302. 9.8 times 3. Go ahead, use your calculator. My guess. minus t equals 2a. Now I have two variables and two unknowns, so I should be able to solve. This system is very easy to solve because one's plus t, one's minus t. So I can just go ahead and add those two equations together, right? These just cancel out and solve for a. Go ahead and do that, see what you get for a. What do we get for a? 1.79 meters per second squared. Determine each acceleration, they should accelerate at the same rate. Both would be moving to the right and to the right. What we call each of their positive x directions. Questions on how we can get one like that? What about now? What if I do have friction? Let's talk quickly. Let's come up with a strategy, and then I'm going to have you guys try to do it. So if I have friction, use of K is 0.1 now. Now what would we do? What would be different? I would have friction on both of them, right? So for this one here, I would have a frictional force in this direction. So I would have F of F here as well. And this one, my frictional force would be which way? Up. It resists the motion. So I'd have F sub F on that one as well. F sub F is all in the X direction. So my 0y, I have 0y. How would I get the frictional force? Because notice I'm still going to add up the X column, right? Still set it equal to 2a. How would I get this? We're going to need the normal force, right? So this time I do need the normal force. The y component is important. How would I get that normal force? Good. So we're going to get the y component for gravity. That's going to be equal but opposite to the y component for normal force. And then that times the coefficient should give us the frictional force, right? Does that make sense? This one's going to be in the positive or negative? The blue one. Negative direction in it. We call this way positive x. So that's going to be in the negative x. What about on the second block, the red block? That was also going to be in the negative direction. Does that make sense? Excellent. Go ahead and find a partner for a group of three. See if we can come up with an answer on part B. Everybody okay with getting the two numbers here for the frictional forces? About negative 1.7 for the blue one, about almost negative 1 for the red one there. Set up your equation. So negative 19.6 cosine of 60 is negative 9.8. Minus 1.6974 plus t, or t equals 2a. For the red one over there, we've got 19.6 cosine 30. That same 16.974 minus 0.98 minus t equals 2a. Add them together gives me 4a equals 4.4966. Divided by 4, I get 1.12. If notice it slows down a little bit, seems as though that makes sense to me. What if we got a negative answer? What if we worked through all of that and then that answer was negative? What would that tell us? No. they both be accelerating at the same rate. You know? So like, are they going to keep equilibrium, or is it going to fall one way? It's going to, the whole thing is going to accelerate. Yeah. Okay. Yeah. In that direction. Yeah. So notice it slowed it down. This is good. It probably should have. What if we got a negative acceleration? Would it be going the other way? Technically, that would mean if I get a negative acceleration in the x direction and I call that way positive x, that means this whole thing's accelerating this way, right? The problem is we assume friction to be in the negative direction, right? Does that make sense? What that would simply mean is friction is too much that it's not moving in the way that we assumed it to move, which means we would have to go back and change a couple things. Now, instead of stating that friction's this way, now we would need to say, okay, maybe it is sliding down the incline in this direction. So you would make friction resist that and have it go this way and that way in order to that is very random.
Like, I don't know, I just a lot of stuff.